Morning. Today I'm going to teach you how to write the electron configuration. I'll give you a very simple technique in order to write the electron configuration for any element in the periodic table. All you have to know first at the beginning, you have to know your periodic table. You need to know that the area over here is the area of S block elements. The area over here is the area of D block elements. Over here, except the helium, is the P block element. This one is for the S. And the area over here is the area of the F block elements. What does that mean? I'm going to show you this figure over here. So as I said, all the elements found in this location over here are called the S block elements. As you can see, in the S we have two columns, and this is because S, when you fill it with electrons, it can maximum contain up to 2 electrons. I can have S1 if the element is over here, any element of this column, or it can be S2 if it was an element of this column. So S maximum up to 2 electrons. When we move to the P block elements, P, if we count, it contains 6 electrons. So if you count the blocks here, maximum of 6. So P can take up to 6 electrons. And the D can take up to 10. If you count the blocks over here, you will find that we have 10 blocks. So D can take up to 10 electrons. And down in here, there are a number of like 14 boxes. So F block elements can take up to 14 elements. Now, if I am writing the electron configuration of an element that ends, for example, here, this one, beryllium, let's say. So my configuration will end with 2s2. Why 2? Because I am on line number 2, period number 2, and S because I'm in the area of S block, and Y is 2 because I'm not in the first box, I am in the second box, so I would say 2s2. Let's say now an element is, I am writing the electron configuration of an element that ends here. So for example, this one is silicon. What would be the electron configuration finishing with what? The electron configuration would finish with this line. So I take the 3s2, both of them, and I'm in P. So I would say 3p, 1, 2. So 3p, 2. I'll give you specific examples and detailed examples. So for the S and the P, the line on which you find the S is the period. So 4, 5, 6, and 7, same as the P. So I'm in line 2, 2P, 3P, 4P, 5P, 6P. But for D and F, if you are on period number 4, you will not say 4D, you will say 3D, because the D starts with the third energy level. So I'm in period 5, but I would say 4D. I'm in period 6, but I would say 5D. So you always say N minus 1 for the D. Whereas for the S block and the P block is just N. For the F block starts from here. So the element over here, this one is barium. It has 56 electrons. The 57 is over here. So we always, after the S, go take all the F block element, then go back here to element LU and continue. So F starts with 4F. So it's always N minus 2. So if you are on the 6th period, you say 4F. If you are on the 7th period, you say 5F. Let me just give you a simple example. Let's say you are asked to write the electron configuration of chlorine atom, which is the one over here. So this is the technique that you will follow. In order to write the electron configuration of chlorine, I need to fill those boxes with electrons here, all the way the 2p, all the way the 3s, and all the way the 3p until I reach Cl. So what does that mean? It means that I have to fill the two electrons in the 1s, you do not say 1s1, 1s2, because I'm taking all the s completely, I would go for 1s2. I am taking the 2s completely, I do not say 2s1 and then 2s2, I will simply say 2s2. Next, I have all the p, line number 2, so I would say 2p6. And then next, I move on to 3s2 all the way, and then 3p. But in this 3p, where do I stop? 1, 2, 3, 4, and 5. So I would say 3p5 to reach the Cl. Okay? Now, let's move to more complicated examples. And I'm going to go, I'll give you like several examples and I will tell you how to write their configuration. Starting with beryllium. Beryllium has 4 electrons. In order to reach 4 electrons or to fill 4 electrons, I have 1s2 all the way, and I have 2s2, and that is the electron configuration of beryllium. Let's take the example of nitrogen. Nitrogen is over here, 7 electrons. So I'm going to erase here and write 7 electrons. So I'll take everything where I stopped and then I continue till I reach nitrogen. So 1s2, 2s2, and then 2p, 1, 2, 3. So it's going to be 2p3. Let's take another example, which is the sodium. In order to fill the electron configuration of sodium, I need to do the same as I did for beryllium and for nitrogen, but I have to continue. So instead of stopping over here, I'm going to take all the 2p, so all the 2p, which is 2p6, and then stop right here, which is 3, because I'm in the third line, S area, and only the first box, so 3s1. Let's take another example, which is the silicon over here. So you're going to take all the electrons that you just filled all the way exactly the same, and you're going to continue. Instead of stopping over here, you're going to take all the 3s, so that's going to be 3s2. And we will continue all the way to silicon, which is 3p, simply 2, 3p2. Let's take another example, saying argon. So I'm going to erase this one here. I stopped here. So let's say I want to write the electron configuration of argon. How that would be? So it's exactly the electron configuration of everything I mentioned before, 1s2, 2s2, 2p6, 3s2. But instead of saying 3p2, it's going to be all the way to argon. And that is 6 blocks, 1, 2, 3, 4, 5, and 6. So that's going to be 3p6. Let's take another example, and this time we want to write the electron configuration of calcium. So I'm going to write everything as it is before, but instead of stopping at argon, I'm going to stop over here, and that is 4s2. Next, let me just give you more examples. Saying I want to write the electron configuration of titanium, which is over here. So you're going to do the same, but instead of stopping in calcium, you're going to go all the way in the D until you stop at titanium. So let's write here titanium, and that is 22. Now, as I said, when I reach the area of D block elements, instead of saying 4D, you're going to say -1. So it's going to be 3D. And where is exactly the titanium? It's in the second box. So it's going to be 3D2. Let's take now another example, the nickel. So I'm going to change this and write here nickel with 28 electrons. So instead of stopping at titanium, you're going to go all the way to nickel. And that is, instead of saying 3D2, you're going to, of course, say everything I mentioned before, and you're going to say 1, 2, 3, 4, 5, 6, 7, and 8. So it's going to be 3D8 for nickel. Let's give one more example, And let's take the example of selenium. Selenium is right over here, 34 electrons. So what do we do in this case? So we're going to take all the D, which is 3d10, and then continue all the way in the 4p until we stop at selenium. So that is 4p, 1, 2, 3, 4. That is the electron configuration of selenium. Let me just start taking more complicated stuff. So saying I want to write the electron configuration of yttrium, okay? So yttrium is the one, I'm going to change color, is the one over here. What do I do in this case? So let's change and write here yttrium with the 39 electrons. So you're going to continue all the way, everything mentioned before, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and instead of saying 4p4, you're going to take it all the way 4p6, and then 5s2 all the way, and then you say 4, because remember the D, it's always n minus 1, 4d1. Let's continue with more example. Let's say I am asked to write the electron configuration of antimony, Sb. So I have here Sb with 51 electrons. So instead of stopping over here in 4d1, you're going to go all the way through the 4d, and it's going to be 4d10, and then all the way in the 5, remember 5p, but not all the 5p, you're going to stop at 1, 2, 3, 5p3. That's antimony. Let's take another example. Let's say you are asked to write the electron configuration of europium, the one over here. So let's change the example and write EU with 63 electrons. So instead of stopping at antimony over here, you're going to take all the 5p, so 5p6, then take all the 6s2, and now stop a little bit. Here it says 56, but here it says 71, because the periodic table doesn't continue straight from 6s to 5d. No, it passes first through the F. So you see, 56, then 57, 58, etc. This, when we reach here 70, then we go back to over here. So I'm going to say 6s2, and then I'm going to go down to the F. Remember that the F, you always say n minus 2. So you are in period number 6. So you say 4F. Now, where exactly is the europium? 1, 2, 3, 4, 5, 6, and 7. So you say 4F7. You stop all the way over here. Now, another example. Let's say you are asked to write the electron configuration of mercury, which is 80. So let's write here 80. So what you're going to do, just follow the numbers of your periodic table. You're going to write the same electron configuration, and instead of stopping at 4F, you're going to go all the way through the F. And if you count these boxes, they're 14. So you're going to say 4F14. Now follow the numbers. This is 71, 70. 71 is over here all the way to mercury, to 80. So this is the line number 6. So instead of saying 6D, you're going to say 5D. And all the way to mercury is 5D10. Let's say another example. You are asked to write the electron configuration of acetone, which is over here, 85. So let me write this one, 85. What would I do? Again, I'm going to take all the 5d10, which I said, and then I'm going to go through the P until I stop at AT. And that is line number 6. So I'm going to say 6p5. That is AT. Now, let's take another example, the plutonium, which is right over here. So what do you do in this case? Your electron configuration remains the same. You're going to mention everything I wrote over here. And instead of saying 6p5, you're going to say 6p6 all the way. And you're going to continue 7s2, 7s2. And then, remember, this is 88. Where is 89? It's over here. So that is coming from the 7. So 7 minus 2, that's a 5f. 1, 2, 3, 4, 5, and 6. So all the way until you stop at plutonium. Over here. 5f6. Okay, now let me just give you one more example. Let's say moscovium. Moscovium. So let me erase this and say moscovium, which is the one over here. So let's change the example and say MC 115. So what you're going to do, you're going to write the same electron configuration, but instead of stopping at PU, you're going to go all the way through the 5F. So it's going to be 5F14. Then follow the numbers. Here it says 102. Here it says 103. So you're going to take all the way of this 6D. Remember, the D is always N minus 1. So 6D 10. Then I'm in the area of P. I'll go all the way to this one. So it's going to be 7P3. And that's it. Thank you. And if you have any questions, please write it in the comments.